angles of any magnitude. So here we're going to look at finding specific angles using some knowledge that we already have. So we're going to use our knowledge of 30-degree angles, 45-degree angles, and 60-degree angles to look at some other angles. To do this, we're actually going to draw a circle and put an XY axis through it. And we're going to look at ways on which we can define some angles. So we're going to use our positive x-axis as a 0-degree reference. And we're actually going to measure angles going anti-clockwise from this 0. So all the way up to here is going to give us 90 degrees at the top, 180 degrees over here, 270, and back to 360. And we can keep going around the circle as many times as we want. So if we did 2 full laps, we'd be at 720 degrees. We can also measure negative angles by going the other way. So going this way, we'd end up with minus 90, minus 180, minus 270, and minus 360. And we could keep going around that way as well. So going this way gives us positive angles, and going this way gives us negative angles. Let's have a look if we draw in a 30-degree angle. So we're starting from 0 and we're going to move until we get to 30 degrees. So let's do that. So 30 degrees will be there, and we can drop a line here, make a right angle, and this is our 30-degree angle. And we know a fair bit about 30 degrees because we know sine 30 degrees equals a half, cos 30 degrees equals root 3 on 2, and tan 30 degrees equals 1 over root 3. But how can we use this to get more information? Let's have a think. So we're going to start from 0, and we know if we get to here, that's going to be 180 degrees. But what about 150 degrees? Well, 150 degrees measuring from 0 goes up to here, 90, 100, be like 110, 120, 130, 140, 150 will be about there. So let's draw that in. So measuring all the way from 0 to here is going to give us 150 degrees. And we know we've got 80 to here, which means that here has to be 30 degrees. And draw another right angle triangle. So we can see at the 150 degree mark, it's the same, it meets up with a 30 degree right angle triangle looking back from 180. And this is a really important result. So what we're looking at here is that we're actually looking at 150 degrees is actually the equivalent of 180 degrees minus 30 degrees. They're actually the same thing. And this is more useful to us like this because we know more about 30 degrees than 150 degrees. So if we have a reference angle theta in this quadrant we want to refer to as the 180 minus theta quadrant, because we can see that if we have some angle, like let's say 30 in this one, over here it's 180 minus 30 to give us the same result of 150. If we look at 210 degrees, that's actually going to be 180 plus another 30. And we get the exact same right angle triangle. So here, 210 degrees is the same thing as 180 plus the 30-degree angle. And this quadrant down here, we can actually label with a special result that it's 180 plus our original angle. And if we look at 330 degrees, well, that's just going to be going all the way from 0 to 360 and then coming back another 30. And we get the same right angle triangle. So our 330 degrees is the same thing as looking at 360 minus 30. So another special result in this quadrant, we get 360 minus our starting angle. And these are our important results for each quadrant. Now, something else to consider is going to be the sign of each trig function in these quadrants. In this first quadrant, when the angles are between 0 and 90, all our answers for sine, cos and tan are positive. So if you go ahead on your calculator and put in sine 70 or cos 10 or tan 89, you would find that all of these answers are positive. So let's put a big A here saying all trig functions are positive in that quadrant. Now let's look at angles between 90 and 180. If you went ahead and on your calculator put in sine 100, cos 120, or tan 170, so they're all between 90 and 180, you would find that only sine would give you a positive answer and the other two would give you negative results. So what happens in this quadrant is only sine values are positive. Doing the same thing, in the third quadrant only tan values would be positive, and in the fourth quadrant only cos values would be positive. So if you have any angle between 180 and 270, only tan of that angle would be positive, and any between 270 and 360, only cos results would be positive. So we get the ASTC. And a way to remember that is you could go all stations to central to remember the order in which ones are positive. Now, when using these special results, remember 180 minus theta is actually the same thing as your original theta. So let's write up some special results. So in our second quadrant, if we have sine of 180 minus theta, or cos 180 minus theta, or tan 180 minus theta, they're actually all the same as just sine theta, cos theta, and tan theta. But the only extra thing we have to worry about is which ones are positive and negative. And in this quadrant, this is your 180 minus theta quadrant, and only sine values are positive, which means that sine's positive and the other two are negative. So we can use these special results to work out some values. So let's go ahead and look at cos 150 degrees. Now, to do a question like this, you want to first identify which quadrant you're in. So 150 degrees, we're in the second quadrant because it's between 90 and 180. And our second quadrant result is 180 minus theta. So we'd actually like to express this 150 as 180 minus some angle. So let's do that. So it's going to be cos of 180 minus something to give us 150. Well, that's going to be minus 30 to give us 150. And using the special result that if you have 180 minus an angle, it just equals cos of that angle, and negative because it's in the second quadrant. So this is going to be the same thing as minus cos 30, and we know cos 30 equals root 3 on 2, so we get negative root 3 over 2 for for cos 150. So let's have a look at tan of 315. Well, we want to identify which quadrant we're in. So 315 is between 270 and 360, so we're in the fourth quadrant. So we know we're going to be using our special result of 360 minus theta. So we want to express that like that. So tan of 360 minus what angle gives us 315? Well, that's going to be 45. Now, we have to work out, is our function going to be negative or positive? Because in the fourth quadrant, only a cos function is positive, and we have a tan function, so we know we're going to get a negative solution. And our special result is that if we have any of these scenarios, we just know it's going to be tan of this angle. So if we have 180 minus an angle, 180 plus an angle, or 360 minus an angle, we can basically just get rid of this part and we're left with the 45. Tan 45 is just 1, so we get minus 1 as the solution for that. Just something I need to mention as well is that when you're dealing with negative angles, you can use these same results but working backwards and just putting a negative in front of all of these terms. So this quadrant in terms of negative becomes negative theta. This one becomes negative of 180 minus theta. So you can see that's our second quadrant result, but with a negative out the front. This one becomes negative 180 plus theta. And this one becomes negative of 360 minus theta. So let's just have a look at solving some equations now using these properties. So now we want to solve equations. So we're going to look at cos x equals a half. And we want to know all the solutions where x is between 0 and 360 degrees. And the reason we have to restrict our values for x is if we didn't, we'd actually get infinite solutions because we can keep going around and around and around the circle to get infinite answers. So you'll always have some kind of restriction on your value of the angle, otherwise you get infinite answers. So let's draw up a quick version of our all stations to central, where we're going to label this one as theta, 180 minus theta, 180 plus theta, and 360 minus theta. That's all we need here. So in order to solve an equation, we have a cos function that's positive a half, because there's no negative sign, so it's positive. So if we're having a positive cos function, looking at all values between 0 and 360, remember 0 is from here and 360 is here, so that's just one revolution. Where are the values of cos that are positive? Well, the values of cos that are positive in the first quadrant, because they're all positive there, and the fourth quadrant, because that's where cos is also positive. Now, our next step is to get what I like to call the base angle. And to do that, that's just going to be the inverse cos of whatever we have on the right hand side. So, and if this was a negative, you'd actually be disregarding the negative here. So, but it's positive, so we don't have to do that in this one. So the inverse cos of a half is actually 60 degrees, and that's our base angle. And our base angle actually refers to this theta in these quadrants. So now we're ready to write our solution for x. So because it's in the first and the fourth quadrant, we want the base angle itself. So the 60 degrees becomes one solution. And in the fourth quadrant, That's 360 degrees minus our base angle. So we get 360 minus 60. So our final answers for x are 60 degrees and 300 degrees. And if you went ahead and put those in your calculator, cos of 60 you'd get a half, and cos of 300 you'd also get a half. Let's look at another one. Let's go sine x equals minus 1 over root 2, where x is going to be between 0 and 360. So first we want to identify what quadrants we're in. So since sine is negative, we need to look at what quadrants sine is negative. I'll do these in green. So sine would be negative here and here, because we know everything's positive here and sine is positive here. So sine has to be negative in these two. Next step is to get that base angle, which is going to be the inverse sine of 1 on root 2. Because this is negative, we're disregarding the negative when we take the inverse sine. And we're going to get 45 degrees here for our base angle. And because we know it's in the third and fourth quadrants, we know our results are going to be 180 plus the base angle and 360 minus the base angle. So answers for x are going to be 180 plus the base angle and 360 minus the base angle. So we're going to get 225 degrees and 315 degrees for x. Alright, let's have a look at some more complicated examples. What about sine 2x equals minus root 3 on 2, where x is between 0 and 360. So again, let's draw up our all stations to central. Oops. Just to reference it, so it's 180 minus theta, 180 plus theta, and 360 minus theta. Now what makes things a little bit more complicated in this one is we've got a 2x inside here. So the first thing I like to do is I like to let alpha equal 2x. So we get sine alpha equals minus root 3 on 2. And then because our angle has been multiplied by 2, we actually need to change the domain. So how would you change an x to a 2x? Well, you just multiply it by 2. And whatever you do in this inequality, that's 0 multiplied by 2 is 0, and 360 multiplied by 2 is 720. So we've got a new domain that we have to look inside now, because when this is changed, it changes our domain. So now we need to do 2 revolutions of our circle. So our next step is to find our base angle. And that's just going to be the inverse sine of root 3 on 2. Remember, we're disregarding the negative. Inverse sine of root 3 on 2 is going to give us 60 degrees. Now, sine is negative, so where's sine negative? That's going to be in the third and fourth quadrant, because sine's positive. Oh, they're all positive here and sine's positive here, so we're in the third and fourth quadrant. So our answers for alpha, remember we're solving for alpha now, not x, because we let 2x equal alpha. So our answers for alpha are going to be 180 plus our base angle and 360 minus our base angle. But that was just one revolution around the circle. Now we need to go 2 revolutions around because we need to go to 720. So all we need to do is just take our previous answers and add 360 degrees. Because if you think about it, let's imagine we had 30 degrees here. If you added 360, you'd come back to it and you would be on 390, and it would be right on top of that line and it would be the exact same answer. So we take all our previous solutions and add 360. So in this case, we're just going to write it out like this. So we're going to take that previous answer and add 360. And we're going to take this answer and add 360. So we get our answers for alpha being 240 degrees, 300 degrees. You're going to get 600 degrees and 660 degrees. But remember alpha, we let alpha equal 2x because the original equation is asking us to solve for x, not alpha. So alpha equals 2x. So we can swap out alpha for 2x. And finally, to solve this equation, we can just divide everything by 2. So we get 120 degrees, 150 degrees, 300 degrees, and 330 degrees as our final answer. And also you can see all four, so there's 4 solutions this time, and all of them are within the original domain. All right, one more. Let's look at tan squared 2x minus 3 equals 0. And we're going the domain where x is between 0 and 360. So if we have this situation, we first need to isolate the trig function. So we're going to add 3 to both sides. So we'll get tan squared 2x equals 3. Now we're going to square root both sides. So we get tan 2x equals plus or minus root 3. And that's the best we can do because we can't do anything there. But remember, when this has been modified, we have to modify our domain. When the angle is not just plane x or plane theta, we have to modify our domain. So our domain is 2x, and we need to multiply everything by 2. So we get that. Let's draw up our all stations to central. That's our base angle, 180 minus our base angle, 180 plus our base angle, and 360 minus our base angle. Now this time we've got a trig function equaling plus or minus something. So what this is saying is, where is tan positive or negative? Well, tan is positive or negative in all 4 quadrants. It's positive, negative, positive, and negative. So we need to consider all 4 quadrants this time. So first, let's find our base angle. So I'm not going to let alpha equal 2x this time. We'll just use 2x. So our base angle is going to be the inverse tan of root 3. And inverse tan of root 3 is going to give us 60 degrees. So that's our base angle. And now, remember, we're considering all 4 quadrants because where is it positive and negative? So that means, so we're solving for 2x here. So that means 2x is going to equal to all four special results. So it's going to be our base angle, 180 minus the base angle, 180 plus the base angle, and 360 minus the base angle. So we're going to have our base angle, 180 minus our base angle for the second quadrant, 180 plus our base angle for the third quadrant, and 360 minus our base angle for the fourth quadrant. But remember, we've changed our domain and we need to go around twice, which means we need to take all our answers and add another 360. Bear in mind, if you had to go around 3 times, you'd have to take the second answers and add 360 to those. So now, let's just simplify these first, just to make it a bit easier. 180 minus 60 is 120. 180 plus 60 is 240. And 360 minus 60 is 300. So yeah, so our other 4 answers, we're adding 360 to those. So we're going to have 60 plus 360 is another answer. 120 plus 360, 240 plus 360, and 300 plus 360. So our answers for 2x are going to be 60, 120, 240, 300, 420, 480, 600, and 660. But they're all the answers for 2x. So we need to go ahead and divide everything by 2 to solve for x. So 30, 60, 120, 150, 210, 240, 300, and 330. So we get 8 solutions for x in this case, and every single one of them is within the original domain of 0 to 360.